And good morning, everyone, and welcome to our Drought Conditions Update webinar. For those joining us for the first time, welcome. And for anyone who joined us for our webinars before, welcome back. Today we'll be discussing recent drought conditions as well as the impact on water resources. My name is Claire Mullen, and I'm delighted to be your moderator today. Ange is our producer and will help moderate your questions. Hi, Ange.
G'day, Claire.
Please send your questions through the chat function and we will address as many as we can. Before we start, may I ask for your attention as we cover up some housekeeping items. Our broadcast today will run for 60 minutes with plenty of time allotted for questions. This webinar is also being recorded and the video will be shared with you via email. For first-time webinar attendees, please see some helpful tips on your screen. Please note the chat box where you can send through any questions or feedback. Please use this and not the Q&A box to send your questions, which we will address during the allotted breaks. Ladies and gentlemen, we have a lot of attendees on the line today, so if we can't take your question and it's urgent, please follow up with us after the webinar. Thank you also to those people who sent in questions during their registration. They were very helpful in shaping the content and direction of the presentation today. And finally, I am delighted to introduce to you our presenters, David Jones and Matthew Coulton. Hi David, hi Matt.
Hi, good morning.
Dr. David Jones and his team are responsible for the delivery of the Bureau's climate service. Their activities include climate prediction, monitoring of climate variability, drought and climate change, and working with users and stakeholders to help them better manage Australia's climate. A key part of the role is reducing the current and future cost of natural disasters, working across industry and government to support better responses and enhance preparedness. Matt Coulton and his team work to ensure decision makers in the Australian water sector are supported by information, analysis, insight and data from the Bureau. Water managers across Australia require an in-depth understanding of water availability and water demand in the past, present and future, and the Bureau provides support at all of these levels. Matt is a water scientist with expertise in water policy and resource management. So welcome David and Matt. We look forward to hearing from you today. David, would you like to tell us what you'll be covering in this webinar?
Thank you, Claire, and welcome to everybody online. Hopefully you can hear us loud and well out there across Australia. In the next 50 minutes or so, as you'll be able to see there on the screen, we'll be covering a number of topics related to drought. So first I'll start with an introduction to really what the climatic conditions have shown across Australia in the last 2 to 3 years. So basically, how have we got to this situation, what are the climate drivers and so on. I'll then pass over to my colleague Matt, who's a water expert, who will talk about the water response, which is really the issue around hydrological drought. There's a couple of highlights. He'll look at the Murray-Darling Basin and then also look at Darwin, which is an area which we've been watching as drought conditions have emerged in recent months. I'll then go on to talk a little bit about why have conditions been so extreme. So, the obvious question in many people's minds is why are we in drought now and, why has it been so extreme? So, using our knowledge of the climate system, we'll have a couple of slides looking at that. Finally, and I guess the thing we all really want to know, how will conditions change in the coming, few months to a year? We'll touch on that using the Bureau seasonal forecast. Thank you.
Thanks, David. So we're going to get started today with a poll. Our poll questions today, what rainfall-dependent decisions will you be making in the upcoming months? So the answers we have, answer A is agriculture, answer B is emergency management, answer C is catchment management, and D is other. So we have about 300 people online already. Hopefully that poll's popped up on your screen and you can click the answer. We'd love to hear where you're at, and if it's other, by all means tell us in the chat function. So David, we had a lot of rainfall earlier this year in Queensland. Did that help any with the rainfall deficiency so far?
Look, certainly when we, as people see in the coming maps, there are certainly parts of Queensland which did get a significant benefit from that rainfall. So unfortunately the rainfall did come in a hurry and it also was confined to a relatively small part of Australia. But when we look at Queensland, so you're around Longreach, Mount Isa through to the coast around Townsville, certainly was a great deal of help. Unfortunately, of course, there was flooding. So, I guess sometimes we get a little bit too much rain, which was very much the case during the summer period in those locations.
True. And for our poll answerers so far, we actually accidentally launched two at the same time, so we're just looking at poll one at the moment.
But anyone who wants to answer question two now and in the spirit of it, please feel free to do so. But yeah, if you could concentrate on poll question one, that would be helpful to us. And it looks like answer choice D, which is other, is currently our most popular answer choice by far. And we have asked people to kindly let us know in the chat if the other answer choices didn't fit, what your other option might be. So we have a couple of responses. Samuel saying audit under the Emissions Reductions Fund, information to feed into human-induced regeneration methodology. And Jim saying operating manufactured water assets. Abby to inform urban water supply. So there's a few, definitely a few others coming. Bushfire hazard reduction, burning, implementation of water restrictions. What else have we got here from Deborah? May frame the community comms messages around climate and resilience in the context of actual and forecast weather. So that's quite interesting, isn't it? How are we going with that poll as well? I might give everyone a moment if you haven't already answered. Last chance.
Can I ask you a quick question while we're waiting, David? So we had another question that came in as part of the registration. I know you'll cover it later, but do you want to give us some early answers about the significance of the recent change in the stance of El Nino to neutral?
Well, yes, certainly. So people would have seen the Bureau's ENSO status has gone down to neutral. It is a positive sign, I think, for Australia. When we're in drought and we've been in drought, we certainly don't want an El Nino event. And after about 2 years of neo El Nino conditions, it looks like that has finally departed. So a little bit of positive news there. Doesn't mean the drought will break immediately, but certainly it's the sort of thing we want to see.
Fantastic. That's nice to get a bit of good news. So, Ange, how did our poll results go?
Well, we did get the majority of you responding to us, so thanks everyone who got involved. Once again, the large majority, and I'm talking more than half of our listeners answered answer choice D. However, we did also have answer choice A as the most popular second choice, so agriculture. Any thoughts on that, David, Matt?
Look, it doesn't surprise us. Obviously, drought has impacts on many sectors, and it's good to see that split of attention, and we'll have to cover off on those sectors as we go forward.
Thank you, David. So let's go on with your presentation.
Okay. Look, thanks all. And in the next 10 minutes of our I'll be giving an update on the recent climate conditions and really how have we fared and obviously evolved into this drought. So the Bureau's convention for showing rainfall deciles is hopefully fairly familiar to people. So what I have there is a rainfall deciles for the past 12 months. You can see the scale on the side, so lowest rainfall on record is shown as dark red, moving up towards the average, which is in white, and then above average rainfall to highest on record rainfall in blue. So, a fairly intelligent way of displaying these things. There's a few things to note about the last 12 months, and this is, obviously not the extent of the drought that people experience, but it's sort of a synopsis of where we've been in recent times. You can see most of Australia has been below average rainfall. Now, it doesn't mean all of Australia is in drought, but certainly it means the lived experience of many people is of dry conditions. Over that 12-month period, we've seen an extension of pre-existing rainfall deficiencies. So one area which has turned quite dry in recent times is Northern Australia. We had a very poor wet season, and you'll see the note there that Darwin, for example, had its 7th driest wet season on record, which is pretty significant for those people, obviously, in Darwin, and Matt will touch on that. Probably the area which is, I guess, most significant from sort of a broader hydrological agricultural perspective is the Murray-Darling Basin. You can see, while not all of Eastern Australia, sort of south of the, I guess you'd say around about Longreach and Mount Isa are seeing below average rainfall, the vast majority have, and unfortunately some areas have seen record dry conditions. We have got a history of droughts which might last 1 or 2 years. So, obviously Australia's agriculture and water resources are are well tuned to manage this difficult climate variability we have. One feature about this drought is that it's now gone on for quite a long period of time, and generally speaking, the rainfall, one might say, started to turn off in the latter part of 2016. So 2016 was a very wet year. We had a strong negative Indian Ocean dipole, which influenced our rainfall. Unfortunately, when that declined, a lot of Australia suddenly turned much drier, and particularly so in Eastern Australia. So what I have here is a similar type of display, but broadened out to the 30-month period. So that's including 2 summers and almost 3 cool seasons, so sort of the cooler time of year, typically autumn into early spring. You can see a few areas highlighted in the orange circles. Probably most notable again is the inland east of Australia. So unfortunately, most of Murray-Darling Basin in the display you can see has had very much below average rainfall or lowest on record rainfall. But it has a thin footprint going elsewhere, southwest Western Australia. Unfortunately, our colleagues down there have seen, fairly frequent dry conditions in recent times, and that has continued the last 30 months, so perhaps not quite as extensive as elsewhere. South Gippsland, through to the east of Gippsland, has suffered severe drought conditions, and also parts of Tasmania, so a wide footprint there.
And so just to clarify, that decile 1 means that for the last 30 months, which is roughly 2.5 years, that means if they're in decile 1, they had...
Well, rainfall the likes of which you might only see once every sort of 10 comparable periods. So it's very significant. It's very difficult to map it on in terms of, say, once every 10 years or once every 20 years, but as Matt will show, when we start to integrate things, this is a very significant drought, and certainly, and unfortunately, one of the most severe we've got in our records. Now, it might come as a little bit surprise to people because, of course, we're in the middle of winter and things always feel chilly unless you're in the far north. But another feature of this drought has been very warm temperatures. So what I have there, just focus on the last 12 months, because I guess it's fairly topical and hopefully some people will remember that far back. I've got the Australian mean temperature deciles. And you'll see there in the notes that the last 12 months for Australia has seen record high temperatures during the day. Now, we do know droughts often do see high temperatures, but these are higher than past droughts. So, not only has it been a drought period, but it's also been a very hot drought period. So, clearly that has implications in terms of increased water demand. Nighttime temperatures not quite as warm, about 1 degree above average across Australia, and that's sometimes been associated with some increased frost risk, particularly in inland areas. But I guess the story here is it has been very dry, but it's also been very warm, which makes this drought a little different to some of those in the past. The Bureau has many different statistics, and one thing that we do monitor is really how much evaporation we're experiencing. So this next plot shows what we might characterise as evaporative demand. So you might think about it sort of a measure. If you've got a pool in the backyard or you're dam out in your paddock, what is the sort of water loss that you are losing to the atmosphere simply through the evaporation process? And clearly when there's less rainfall and there's more evaporation, that means droughts tend to be exacerbated. And you can see, unfortunately, as you might expect, dry conditions, warm conditions, we've seen high rates of evaporative demand across Australia. Again, particularly through the Murray-Darling Basin. So, as best as we can tell, not only has it been dry, but the rate of evaporation has also been record high. So it has compounded the drought event. The Bureau has many different ways of looking at the climate and hydrological system, and for graziers, for croppers, for those with farm forestry, for example, an issue that is really important is really how much moisture is in the soil. So, obviously the rain falls on the soil, we lose some to evaporation, and some of it gets stored and is accessible to plants and groundwater reserves, etc. What I have here are 3 snapshots of soil moisture mapped across Australia. And you'll see it's got quite a few similarities to the rainfall maps that I showed previously. They're over longer periods, those rainfall maps, so they tend to be a little bit smoother, and soil moisture does go up and down as rainfall comes and evaporated. But you can see many signatures which are quite similar. So first, across these 3 snapshots, June 2018, February 2019 and June 2019, the Murray-Darling Basin features as quite persistently dry, and what that means is, when you're looking at plants, for example, there has not been much soil moisture there for them to gain access to. So, trees are doing it tough, pastures are, and obviously crops are struggling. Another area which has emerged, particularly in 2019 is in the Northern Territory. So see, for example, while it is a dry season up there and you do expect it to be dry, the dryness in the soils is actually approaching record lows in that region. So again, we're seeing dry soils widely impacting Australia over many diverse areas for a long period of time.
So it's dry on top and dry underneath as well? Yeah?
Unfortunately so, and that's often the signature of drought. So as the rainfall declines continue, it tends to cascade through our systems. There are meteorological, hydrological, climatological perspectives on drought, and the question is, how has this been manifested, and how has this been felt as people's experience? So, what I have here is a product we derive from satellites, and what it does is measure how green the vegetation is. So, obviously, when you look out on a green paddock or on a green field of grass, the greenness, it looks very attractive, but it's also telling you how much productivity you're getting from that crop or that pasture and so on. And when your plants are browner, it means there's less photosynthesis going on. It means there's less growth. It means there's less vegetation and so on that can be consumed by animals, etc. We go from brown values in this plot to green colours, and you can see there's not too much green, unfortunately. So this is looking at the last 6 months across Australia. You can see very dry conditions, and unfortunately the vegetation has responded as you'd expected. So if not record low values of greenness, certainly very, very close to record low values. So the whole of Australia at the moment is remarkably brown. There's not too many green areas in a historical context. And those areas which are green are actually those which were affected by the floods during summer in Queensland.
Would you know, Gareth has just asked us how granular is the resolution on the NDVI?
Typically, we map these problems at about 5 kilometres resolution. So there will be some details in there which we may miss, but that's typically the scale. So around about 5 to 10 kilometres, and sometimes we can even do a little better.
Yeah, thank you. So we're having a question and answer session. So if you have any questions, please send them in. David asked, is white normal on that NDVI chart? There's not much white at all. It's really just brown, isn't it? With a bit of green in Western Queensland. Yeah,
so white is in the average in normal conditions. Now, of course, normal sometimes is difficult to find in Australia because we get so many variations. But that picture just really shows almost all of Australia, unfortunately, is brown at the moment. So not much green around, at least when compared to what the average should be.
Yeah, and I think the soil moisture map that you showed us, all of that's available on our website as well, right?
Look, absolutely. Everything the Bureau produces is available on our website, and of course we also distribute it through our various products, our reports and our social media. So widely available.
Thank you. Matt, we had a question that came in as part of the presentation. How much snowmelt results in inflows into major storages?
Yeah, so thanks for the question. It's a very good one, a very interesting one. So firstly, looking at these slides, just ignore the map on the right. It's a bit confusing for the time being. But the map on the left shows notionally the parts of Australia that are above the snow line. So snow line is a bit of an arbitrary definition, but essentially it's parts of the country that at least would have snow cover for 1 month of the year, and in a good year would have 4 to 6 months of snow cover. The really dark green is the tree line, so it's how high you have to be before trees stop growing, and you'll see that's a very, very small part of Australia indeed. The point of showing this map is to show how small that area is. So in the Murray River catchment, so the part of the country that contributes to inflows into Hume and Dartmouth Dam and then down the River Murray, only 7% of the catchment is above that snow line, which means that the contribution from snowmelt is quite slow. Annual snowfall is very variable in Australia, and the snowiest parts of the Australian Alps are actually on the eastern side of the Great Dividing Range, so that snowmelt flows east. It's also important to remember that not all snow melts and becomes runoff into rivers. There's also a process called sublimation, where snow directly evaporates, which means we don't actually get water out of that. The other important thing to notice is some of that eastern flowing snow we get ends up in the snowy hydro system and is transferred back to the west. So while that's a relatively small volume of water, it's very, very reliable. The map on the right, what I wanted to show there is the colours in the background show the average runoff that we get in these parts of the country. So the purple and pink colours is where we get the most runoff of anywhere in the Murray-Darling Basin. So the rainfall that does fall in this part of the country is very, very important. So even outside of the really snowy areas, the rainfall that falls in the upper Murray and Murrumbidgee catchments, you know, between Canberra, Tumut, Albury, and the mountains is a really important contribution to stream flow.
Thanks, Matt. When we had a big dump of snow last weekend, so it was a great, timely question, but it might take a while.
Yeah, so when we had
up and not much of it.
Yeah, so we had some early snowfall this year, but then it melted very quickly when we had some warmer rain. That actually can cause a flood risk as well. Is when you get warm rain falling off snow, you tend to get a lot of runoff very quickly. And you actually notice that we do have some warnings at the moment in the Kiwa River in Victoria for people to keep an eye on that.
We've had a question, thanks Matt, we've had a question from Philip. While this is the worst drought in history, are there analogue periods in the past that are similar in nature or time frame? I think you're getting to that later, maybe.
Yeah, so that's a very good question. And the definition of what is worst is obviously, it can be difficult because different people have obviously different experiences. But when we do look back through our record, I guess there are two droughts which, you know, in some ways similar to this one. The first one's the Federation drought, which was, it was a long drought that also for a period was a shorter sort of multi-year drought and very severe. So the Federation drought around about 1900 is one analogue. The other analogue is the Second World War drought. So during the Second World War, a lot of Eastern Australia suffered a multi-year drought and was very severe. So there are examples of similar droughts in the past.
Thank you. And we had one other question from Neil. Has the definition of drought or the criteria changed over time, or is it consistent? I guess it depends on what type of drought.
Look, it does, and you know, certainly the Bureau has not changed its definition since the 1950s, so we typically look at rainfall deficiencies, but you know, what it means obviously does change through time as people, you know, adopt better practices.
Thank you. Matt, I think you're going to go on with the next part of the talk.
Yep, so for this part of the talk, we're going to have a very quick look at the water resource conditions nationally, and then dive into two case studies in the Murray-Darling Basin and in Darwin. So our first slide here shows storage levels over the past 3 years across the country, looking state by state. What is quite interesting here is that the last 12 months, so you see the difference between where we are now and that pink line, every state has actually experienced decline. As David was saying, the last time we had a really wet year in Australia was 2016. I've highlighted in those orange circles in New South Wales and Victoria how significant that rain in the second half of 2016 was to Southeast Australia. It essentially put our storages back at a healthy level. You can notice a similar spike early in 2017 in the summer of 16-17 in Western Australia, but since then we haven't had really significant inflows over a wide area of Australia. The one exception you'll notice is in Queensland, where you can see a very big spike earlier this year, which was associated with tropical cyclone Trevor and that slow-moving monsoon trough that we had, and we actually had dams and at that time over 200% capacity. This is looking at sort of a different perspective. So each one of these circles on the map represents a dam or a set of dams in a particular catchment, and the colour represents how full they are. So the first thing to take away from this is most of our water storage is in Southeast Australia, in the Murray-Darling Basin. That's where our biggest storages are, and they're all looking pretty poor, particularly in the northern Murray-Darling Basin where those brown circles are. That's showing that those storages are very close to empty. If you want to look at any more information on our storage levels, we have a handy app you can download from the App Store. So our first case study is looking at the Murray-Darling Basin. I'm sure everyone has seen something about the Murray-Darling Basin on the news in the last year or two. As we've seen dams run empty, we've had some fish kills, and we've seen record low stream flows. So the first thing to sort of try to understand this drought is looking at rainfall. On the slide on the right, you'll see the grey outline is the edge of the Murray-Darling Basin, and the blue lines represent the rivers. That darker black line represents the catchment area for the Barwon River, which flows into the Darling. So essentially that area is where the water that feeds the Darling River system and down to the Menindee Lakes comes from. As you can see there, all of those dark red patches show the lowest on record rainfall totals for the past 2 years. David earlier referred to the analogue of the Federation drought. So as of, I think, last month, we've actually exceeded the record for the lowest rainfall over a 30, 24-month and 18-month period. That record was previously set in the Federation drought. So just moving on from that one, I wanted to show actually where the water that flows into our storages comes from, because it's a really small part of the country. So the areas that I haven't greyed out there are the areas that feed into our major storages in the Murray-Darling Basin. And as you see, they're all below average rainfall, and those ones in the Northern Basin, sort of north of Tamworth and between Tamworth and Toowoomba, all have lowest on record rainfall totals, which really goes some way to explaining why our storages and our rivers are so dry at the moment. Looking back at the longer term, a lot of people in our living memory remember the Millennium Drought. So these lines here go back to the year 2000, and you can see through 2002 to 2010, it was a relatively dry period. There's two important points to take away from this, and one is the difference in the climate between the Northern Murray-Darling Basin and the South. The South, as you can see, is very seasonal. Even when we have dry winters and springs, you still generally get a small recharge, whereas the north is far less seasonal. So it's actually slightly more summer dominant in the north, but hugely variable. One thing worth noting is that those wet periods, say the summer of 2010 and the winter and autumn of 2016, you see really rapid filling of our storages. So often we have these wet periods, our dams fill up, and we sort of stop worrying about the drought. However, when we move on to groundwater storage, we don't notice these same signals. So the areas highlighted here in pink represent our groundwater levels in some of our major aquifers. The top one is in the Guarda Aquifer near Moree, and the bottom one is in the Namoi Aquifer at Weewar. And as you can see, the seasonal drawdown in those aquifers is more than the recharge we're getting each year, and we're not getting that level of recovery that we see in our surface water storages following very wet events. A couple more examples further south in the basin. The top one is in the Macquarie River alluvial aquifer, which is near Narromine. As you can see, the levels there are well below anything they were in the Millennium Drought. The other one is in the Lachlan near Hillston, and it's a similar story.
Thanks, Matt. Can I just throw you a couple of questions?
Yep.
Gareth asked us, where are the north-south boundaries, please?
So essentially the northern Murray-Darling Basin, go back to here, are all the rivers that feed into the Darling River. So the Darling River is what you see between Burke and Menindee. All the rivers that feed into the Darling River there are part of the northern basin. All the rivers that feed into the Murray River at Mildura are the southern basin.
Fantastic. And we had a question from Sandy. You told us about the app where you can get water storage levels. She was asking about groundwater storage levels.
Yes, so the Bureau of Meteorology has 4 groundwater information products depending on what level of depth you want to get into, but I actually have a link at the end of the slide at the end of this presentation to those resources, but if you just Google Bureau of Meteorology and groundwater, it'll take you straight there.
Thank you. And one more from Merrick. How do the groundwater levels interact with surface water storage?
So I guess surface water storage tends to be a quicker response. So if you have wet periods, you'll see dams filling up quite quickly. Once the catchment gets wet upstream of the dam, it'll start producing runoff, whereas the response we generally see in groundwater is a lot slower. It's sort of, it is a much more slower response mechanism that if you have a longer period of wet times, then you start getting more groundwater recharge. But if you have those short, sharp events, it doesn't tend to impact our groundwater reserves the same way it does our dams.
Thanks, Matt. I think you had another case study to show us.
Yep, so moving to Darwin, which is a very different example, and you might wonder why I've included some of these pictures which seem very unrelated to Darwin on this slide, but there's a number of places in the world where there is communities used to having a very regular very regular, very seasonal rainfall. So you might recall Cape Town was in the international news a lot recently. They had a very seasonal filling of their dams. They had a couple of years where that seasonal rainfall didn't eventuate to the same extent and they ended up in trouble. The city of Chennai in India has been in the international media lately. 10 million people, very dependent on monsoonal rain, and it just hasn't been delivering the way it has been historically. Darwin is nowhere near as extreme as those examples, but there's a bit of a similar story eventuating. So firstly, as David mentioned, the wet season in Northern Australia was well below average. I think you said 7th lowest on record. You know, not extreme, but noticeably less than normal. So that's the first part of the story. But when we look at the groundwater levels in the Darwin region, we see that very seasonal recharge. And I've highlighted there the recharge that has come from this wet season and just how small it is. It's important to note that Darwin's groundwater systems provide fresh drinking water to 30,000 people, and 50% of the Northern Territory's total crop and hay production comes from the Darwin area, and that's a $122 million industry. So there's a really great resource on the Northern Territory Government's website to track how this is going, but they note that essentially for 30 years, Darwin has had a really good, reliable seasonal rainfall supply, and we've sort of become used to that, and when it doesn't eventuate, we start running into some of these issues. So to respond to someone's question earlier, this is where you can find a lot of groundwater information, so you can do everything from download data if you really want to do some analysis yourself, you can observe trends, or you can just read some analysis that's been produced by our experts here at the Bureau. And if you're really interested in the Darwin story, that second link below is the Northern Territory Government's website. It's a really good page.
We did also run a webinar on groundwater if anyone's interested in having a look at the Bureau's YouTube channel.
So your recordings on our webinars page on the website. Thank you, Matt, that was excellent. So now we're going to have a go at poll 2 and also take some questions and answers. So Ange has just launched poll 2. It's an interesting question. How much rainfall ends up running off into rivers in the Murray-Darling Basin? Is answer A 50%, answer B 30%, answer C 10%, and answer D 6%. I was quite surprised by the answer when I found out earlier. Yeah. So it'll be interesting to see who has some ideas about that. Let's go to our questions. So we had a question from Claire Miller before. She asked us, do you have the groundwater recharge and drawdown graphics for aquifers in Northern Victoria and New South Wales, Murray and Murrumbidgee?
Absolutely, and I know Claire, so good to see you here. You can produce those on the Bureau's public webpage, but if you have any issues, just drop us an email. There's an address at the end of this presentation, and I'm happy to send them through to you.
Fantastic, and please send your questions through to the chat. We've had a few, David, about the severity of this drought. So you told us there's kind of been 3 significant this century, so how does this one rate so far? Can you comment?
Yeah, look, it's a really difficult question because every drought in Australia is different. So, you know, if you're looking in Southern Victoria, for example, the standard drought is clearly the mean drought still, for us. I think it's sort of the general picture across the Murray-Darling Basin for droughts lasting 2 to 3 years. This is the most severe drought we've now seen in terms of the rainfall totals and probably also in terms of the general runoff or general runoff into dams. So it's certainly about the most severe in 120 years of records. We do have, some limited paleo records going backwards in time, and there certainly has been severe droughts in the past. You can't really compare this to those prehistorical droughts, but certainly this is about as bad as it's got in our record, so it is pretty severe.
Pretty tough with a whole lot more people, right?
We haven't had too many responses to the poll that we've released. So, ladies and gentlemen, if you're struggling to locate it, it should be on the right-hand side of your computer screen. The answer choices, again, A at 50%, B at 30%, C at 10%, or D at 6%. If you are struggling to navigate the poll, you may also let us know your answer choice in the chat and we can view it from there. Do we want to take any more questions while we wait a moment for this for people to get their answers through?
I think we can. I had a question for Matt. So when I looked at those numbers, I said, why isn't the answer 100%? Why doesn't it just come out of the sky and go straight into the river?
So essentially, the Murray-Darling Basin is very flat. It's one of the flattest river basins in the world, and as David showed in his presentation, it's pretty warm and evaporation rates are very high. That means that most of the water that falls in the Murray-Darling Basin is either evaporated from waterways and floodplains, or it's transpired by plants. Transpired means the plant uses it and it goes back into the atmosphere. So 86% of the Murray-Darling Basin land area actually produces next to no runoff outside of a drought. It is really flat, it is really hot. Are we answering the question yet?
Yes, I've actually closed the poll off and I'm sharing the results there. But and again, it's interesting because I certainly didn't get the answer to this question right when I first heard it. But the majority of our respondents did answer. Oh, actually, no, they said C, 10%. 10% followed by D, 6%. So are you going to put us out of our misery?
Yeah, so I know there's a few people tuning in from the Murray-Darling Basin, so I know that they'll be getting this one right. But yeah, so 95% of the water, 94% of the water evaporates and is transpired by plants or evaporates directly from the soil, which means only 6% is really left as runoff into rivers. It's really, really important in the Murray-Darling Basin where the rain falls. If we're in those highland catchment areas above our dams, you tend to get good rates of runoff. If it's to the north and west where it's very flat, it has enormous local benefit like any rain does, but it doesn't tend to produce much runoff into our rivers.
Thanks, Matt. So we really do rely on every drop. Okay?
Yeah.
David, I think you're going on with the next session.
Look, thanks, Paul. And I guess the question, we all know the conditions that are out there, and we've seen, a good scientific analysis of the water situation from colleague Matt. And, the question that comes to mind is really, why have conditions been so extreme? And, of course, there are limits to what the science can tell you in real time, but certainly the Bureau is looking very hard at this, and I'll, in the next few slides, give some of our insights when we look at this event and, how our models behave and, what history tells us. I think I'd be surprised if anyone on the line hasn't heard about the El Nino, subtle isolation and the Indian Ocean dipole. So, when we look at our historical droughts, there's two features which tend to appear prominently in our climate records. The first one is El Nino. So up at the top right-hand side of the display, you'll see there an illustration of El Nino. Typically, El Nino means warm water in the Pacific Ocean, certainly the Central Pacific, and then also actually move east towards the Americas. And El Nino, unfortunately, takes the rainfall away from Australia on average, increases rainfall out towards South America, and decreases the rainfall over Australia. The other drought driver we tend to look for is a pattern in the Indian Ocean called the Indian Ocean dipole. And there's something very similar to El Nino in the Indian Ocean dipole called a positive Indian Ocean dipole. And in the case of positive Indian Ocean dipole, we see warm waters out towards Africa, which increases rainfall in places like Kenya, Mozambique, Somalia, so those countries on the east coast of Africa. And unfortunately for Australia, it tends to decrease the rainfall in our region due to average or cooler than average temperatures in the ocean, as you can see there. So what have ocean temperatures been like in the last 12 months? Is there a suggestion that these two drivers have been at play? And I'll put there illustrative red thermometers showing all the warm water in the Central Pacific and also in the Indian Ocean. And in our region, sort of average or cooler than average waters. So I think the first message there is a role for the Pacific and the Indian Ocean here. While we haven't quite hit the mark on an El Nino event declaration, we've certainly been very close. Very close for a long period of time. And both the Indian Ocean and Pacific Ocean are sitting there in the background and unfortunately drying Australia's climate.
So this drought of a couple of years has come from both those factors?
Unfortunately, both the Pacific and Indian Ocean have been unhelpful to our rainfall. And the Indian Ocean continues to be so. We're currently on the verge of a positive Indian Ocean dipole event.
And if you've never heard those terms, there's plenty of information on the Bureau's website to explain them, and a little video as well, I think,
That's right. We've recently put out a couple of videos and lots of illustrations, and of course the Bureau is always happy to help, so certainly Google us. Obviously we've all heard about climate change, and the question is this drought, is there something about this drought which is different from past droughts, or is there something that might be attributed to longer changes in our climate? And it turns out there is actually a change emerging in our rainfall in southern Australia. So what I have there in that plot is the rainfall for the last 22 years for the cool season. Now, the cool season is typically defined as April, October. You can think that's the period of time when we get the cold fronts and the low pressure systems basically impacting on southern Australia, occasionally penetrating as far north as our border with Queensland and impacting on places like Brisbane. But they're the systems that tend to bring the bulk of the rainfall in southern Australia and really are the drivers for our cropping systems and our runoff in southern Australia. What do you see for the last 22 years? You can see there that almost all of Australia has had below average rainfall persistently for the last 22 cool seasons, and unfortunately a number of areas have had the driest 22-year consecutive cool season period on record. So the question in our mind is this a drought in all these regions, or is it that the climate's becoming drier through time? And when one looks at this, certainly there is significant variability in our climate system, but it does appear, as we might have expected, that the cool season drying in southern Australia is probably exacerbating the drought in some areas. And it's worth noting it's not just Victoria and southwest WA, certainly parts of Tasmania, stretching up into New South Wales, and also along the spine of the Great Dividing Range. So there is clearly a role for the drying trend. I did mention previously about it being a hot drought, and anybody who knows Australia's history knows heat waves have been a pretty regular and unpleasant occurrence. We're going to have in our records mass deaths in towns like Bourke in previous drought episodes. We know it can get very hot, particularly during drought events. And the question is this drought hotter than previous droughts? What I have there in the graph is mean temperature averaged across the Murray-Darling Basin. Going back to 1910, the reason why we picked 1910 is it was just after the Bureau was created, and one of the first things the Bureau did at that point was roll out weather stations which were consistent. So we've got pretty good, if not, very good records across Australia going back to 1910. I've highlighted the 1914-15 drought. That was a particularly bad drought in a lot of eastern Australia, and you can see, as you might expect, that was a hot drought, nearly 1 degree above average. But the recent drought, unfortunately, has been that much hotter again. So typically the warming is about 1 degree, and you can see, along that line, we've seen that warming. And yes, it has been a hot drought, but it's been hotter than some of the previous ones. So again, some signal there in terms of the underlying trends.
So what that graph's telling us is that in 1914-15, it was at least half of a degree above average. And at the end of the graph now, we're about 1.5 degrees above average. So it's a hot drought.
It's a hot drought. So the warming, which is a little over 1 degree now for Australia, simply means, our droughts, which have always been hot, always given us unpleasant summer temperatures, are that much hotter again. So that means this drought is a bit different. What we expected in the past doesn't necessarily apply to droughts in the present.
And hot drought means less rainfall, in essence.
Potentially, it does increase evaporation. It also means things like livestock, for example. Let's think in terms of cattle, for example, you'll get a tendency for them to, basically require more water during hot periods. Say poultry, for example, if you have poultry in Victoria, you might need to turn your sprinklers on and use water. There's all these various things that one has to do in terms of supplementing water during high temperatures. So there is a change there in basically how the drought is felt. And we also know high temperatures add to the drought stress. So plants, for example, if they're dry, that's bad. If they're hot and dry, it tends to be worse. So, clearly not a good thing.
So getting less water and needing more water. So it's a bit of a double...
basically in summary.
Okay, so will the season ahead see relief?
So, look, thanks all. So what we've done thus far is really sort of characterise what we've seen for the last 30 months and, how conditions have evolved as we move through 2019. I guess the first question that anyone asks is this drought likely to break and how soon? Now, obviously droughts do come and go, so there is a positive there. We do expect seasonal conditions at some point in the future will improve, but when we look at, say, the next 3 months, how realistic is it that we will get enough rainfall to basically break this drought through the Murray-Darling Basin? That's a fairly complicated piece of analysis, but what I have here is a display basically saying how much rainfall would we need between July and September to basically provide some level of easing of the drought. So not really what would say break it, but certainly provide a fair bit of relief. And what that shows really, we need to get, in some places, actually record high rainfall in the next 3 months just to provide, some material relief in this drought. So unfortunately for a lot of Australia in the next 3 months, it's not the time of year that droughts are likely to break. We know the spring tends to be quite dry. When the drought's more likely to break, very often during the summer period. So certainly at this point, we'd be looking more towards later in the year or over summer for a general easing of conditions if we go by history. What does the seasonal outlook look like? Now, hopefully people are fairly familiar with the Bureau's seasonal outlook. We, every fortnight and fairly soon every week, we'll be producing a forecast of the next month, the next 2 months and the next season. And what I have here is a first look for the August to October period. Now, previously mentioned, we have a positive Indian Ocean dipole or a near positive Indian Ocean dipole in the Indian Ocean. And unfortunately, that is inducing a dry map in terms of the outlook for the coming 3 months. So, unfortunately it is dry out there, and when we look at the next 3 months, the prospects for near-term relief are pretty limited across Australia. So it doesn't mean it won't rain, it doesn't mean we won't see some good rain in pockets, but the prospects for good relief rainfall in the next 3 months, unfortunately, don't look too good. So it's a case of hanging there, I guess. One thing to keep in mind, of course, these are probability forecasts. The reason why we put them in probability is because there's no perfect forecast when it comes to climate. We know sometimes we can get a low pressure system in the 3 month period, which is unexpected. Sometimes we might get lucky with a series of fronts. So there will be people who do better than this picture suggests, and that's why we present in probabilities. So there is always a hope that we do see good rain, if not generally, at least in pockets to provide some level of relief.
So that means it doesn't mean it won't rain, it's just not as much as we would like, yeah?
Look, absolutely, and that's always a thing to keep in mind. These aren't statements that we will be dry, and they're not statements that it won't rain. We will get rain. It rains certainly across southern Australia in the August-October period, fairly reliably, but it tells us the chances that rainfall is going to be above average is reduced. So the chances of really good rainfall is lesser than it would be typically for this time of year.
Not on the current outlook.
Case of watch this space, we will update these forecasts regularly, and fortunately we've seen the El Nino revert back to neutral, so that's a positive sign. We would expect these maps to start to green up as we move towards summer, so fingers crossed. When we look at temperatures, the pattern of warm temperatures we've seen do look like continuing. So what I've displayed there is just a maximum temperature forecast, but we have a similar forecast for minimum temperatures. The story is spring's likely to start early, one might say, so above average temperatures as we move into the second half of winter and into spring. So an early start to spring and I guess in northern parts of Australia, an early start to those hot temperatures. So again, I guess there's a message there in terms of preparedness. We have dry conditions and it's likely to warm up fairly quickly.
Thanks, David. We've had a heap of questions. We've got more than 300 people online, so we'll get through as many as we can. Sue asked, what explains poor recharge rates in groundwater storages in Darwin? Matt?
Good question, Sue. So I don't want to go back through the slides because we might get a bit confused, but essentially a big part of it is less rainfall, but you'll also notice that soil moisture is well below average. So I guess when you have a dry soil and you only have a small amount of rain, often what happens is water will seep into the surface soil layer and then evaporate from the soil, so you don't get that same level of recharge as you get when you have a really big summer wet event and you get the soil saturated and you get lots of groundwater recharge. I really encourage you, if you're more interested in this issue, visit that Northern Territory and Government webpage. They have a lot of good analysis and a lot of good explanation of what they're doing in this space.
I think, pardon my ignorance, the wetting up the sponge concept, is that true or not?
Yeah, a little bit. I guess there's a difference between not all of the water that goes into the top layer of soil ends up in groundwater. So if you just get a small amount of water in the soil, and then especially if it's hot afterwards, then that water can evaporate straight from the top soil rather than going into groundwater.
Thank you. Peter asks, how much percolates to groundwater? Do we know?
I think that was probably a broad question about the Murray-Darling Basin. I'm not sure I can answer that one at a whole level if anyone could. But groundwater use in the Murray-Darling Basin is mostly focused around shallow aquifers that are very close to our major river systems. So there's lots of good maps on our groundwater webpage, but what you'll see is that where we have most groundwater uses in these shallow alluvial systems, which are closely linked to our rivers. So it's not that groundwater is a completely separate resource to our surface water, they're highly interconnected.
Got it. Thank you. From Robin, how much wetter is the inland, as in Northern Territory, WA, Queensland, getting in the cool season?
So, yeah, look, that's a good pick-up. We have seen a period of above average rainfall in the northern inland of Australia, and that, in fact, actually carries over to the wet season proper in the northern parts of Australia. So while we've had a drought in the last 12 months around Darwin, northern Australia has tended to become wetter over the last 20 or 30 years as southern Australia has become drier. In terms of the cool season, the effect's fairly small. It's a very dry part of the country during the cool season, but even though it is dry, it is actually getting wetter. Is it agriculturally significant in the cool season? Probably not, but certainly I guess it's a positive sign for those people who live in those areas.
Cool. From Lyndon, how does the rising temperature compare against the paleoclimatic data?
Well, that's an excellent question. The question is, are we seeing things which are unusual when we look back for our past? Now,
oh, sorry, she said maybe the better question is how this all stacks up against paleoclimatic.
So I guess there's many ways to answer that. When we look back through our sort of more detailed paleo data, I say over the last 500 years, the latest period does look unusually warm, and that's no surprise when we know all about the enhanced greenhouse effect, and that's clearly warming our temperatures. When we look back over the very, very long paleo record, which goes back some millions of years, we have had warmer temperatures 2 or 3 million years ago across Australia. We're probably starting to approach those. We may not be quite there, but certainly we're approaching those. So, I think the general view is globally we are approaching temperatures which will very soon be the warmest in about 2 or 3 million years. But there's a fair bit of uncertainty in those reconstructions. But yeah, what we're seeing now is actually quite significant.
Thank you. And a related question from Michelle, given records commenced in 1910, is it possible to demonstrate longer-term trends over thousands of years?
It's an excellent question, and it is, Australia is blessed with some very good paleo reconstruction. So we can look at, say, various isotopes. Isotopes are basic chemical signatures in sediments, also in shellfish, and also in corals. We can also look at tree rings. So there's many different ways of looking at variations in climate going past. And what they generally show is this. The recent droughts have been quite severe from a very long historical perspective, and also temperatures have been remarkably warm. Probably the warmest in at least quite a few hundred years, and quite possibly now getting up well over 100,000 years.
Thank you. We had a question from, I think it was Stuart. He asked, August to October outlook is consistent with what often follows quite low SOI, Southern Oscillation Index values at this time of year. Do you have a comment on that?
I think that's certainly true. We have seen El Nino-like conditions in the Pacific Ocean for quite some period of time, so there is certainly some consistency there. I think generally though, the Bureau is looking at the Indian Ocean as the main driver of dry conditions in the coming 3 months. So with a positive Indian Ocean dipole, we do expect below average rainfall. So it is all fairly consistent.
Thank you. All our questions seem to be about rainfall so far, Matt. Sorry, it's all for Dave. So David asked, to what extent has the very warm conditions in the Central Pacific Niño 4 caused the drought and driving the ASO, August, September, October forecast?
Look, that's a very good question, and it's going to take a great deal of scientific analysis to disentangle the various factors that have had an influence here. But most definitely, the Pacific has been warmer than average for quite some period of time. Certainly the last 30 months, we've seen very warm conditions out there. And that is a pretty classical drought signal for Australia. So I think absolutely, can we give a number? Is it 50% or 60%? I don't think we're at that point in time. But certainly it is consistent. It is a driver of this drought. And hopefully, as those temperatures cool, we'll see some relief.
Thank you. Mark asked us a question about those high pressure systems over recent years. Been a feature that they're being blocked. Is that due to the southward movement of the subtropical belt? And if so, is this going to be a permanent climatic feature? We've got some pretty learned people online today.
Yeah, we have.
You have a good answer?
Probably need about an hour and a half to explain all the details.
Follow-up
I'm
webinar.
sure that, no, I'm sorry, I don't have that long.
Certainly, it is a good point. The high pressure systems are increasing across southern Australia, so people did see the rainfall map there for the last 22 cool seasons. Southern Australia is becoming drier. The reason why that is happening is because the highs are moving poleward, so we're seeing some contraction of the front towards the Antarctic. So there is a climate change signal there. Is this drought because of climate change? It's much more complicated than that. We've got natural variability, and we always have.
Yeah, that's true. We had an interesting comment from Ken. He said, spring's coming early. I had my first magpie attack for the year 2 days ago. The calendar hasn't quite kicked over, and I'm not sure about our magpie index, but that's Ken's observation. Lydia asked, how has flooding earlier this year impacted Queensland's drought outlook?
So I guess I think David referred to this earlier, Lydia, but a lot of the areas that received rain in late summer received floods. So you would have seen some of the devastating impacts in Western Queensland on livestock and on those farmers. There was, I guess, not a lot of area that was between the areas that got lots of rain and the areas that didn't get any rain. So, for example, when you get to the southern parts of Queensland that are in that northern Murray-Darling Basin, only a very small amount of that summer rain made it into the Murray-Darling Basin. That fell north of Charleville in the Warrego and Peru catchments. As I was saying before, that part of the basin is very flat, so there's been some tremendous benefit in that southwest corner of Queensland in parts from that rain. There's a lot of wetlands and lots of very fragile, very important ecosystems that have benefited from that, but it hasn't flowed through into the basin more broadly, and it hasn't really benefited any of that area of southern Queensland.
Thanks, Matt. We still have a heap of questions. We're going to take the last one from Craig now so that we can still finish at 12 as we promised, but speakers, if you're available for a couple more minutes, we might keep going once we've wrapped up. The last one from Craig, he was asking us about, is that an unusual pattern having both the positive Indian Ocean dipole and El Nino around at the same time?
Not really. So we often do find a positive Indian Ocean dipole and an El Nino do coincide. Not all the time, but perhaps 75% or thereabout of the time. So it is unfortunately an unlucky occurrence when they both interact. We have both the Indian Ocean and the Pacific Ocean looking to dry out Australia. And, given we've had these in our climate system, again, it's not surprising it has been a fairly dry few years across Australia.
Thank you. We might flip to the summary real quick. We had a great compliment from Nick saying, thanks for all this material. He really liked the how much rain do we need. That was of most interest to him. Can you summarise our talk real quick and we'll wrap up and then maybe take a couple more questions for those who have to leave us.
Yep. So I guess in terms of the observation, David's section highlighted that we have a growing multi-year drought affecting much of Australia. Particularly in the southeast, that drought is stretching back, to the 2.5-year timescale. We have had really significant rainfall or significant inflows since the winter and spring of 2016 in eastern Australia and since the summer of early 2017 in the west. The drought has increased in intensity and extent over the past 12 months, and it's been really hot. So there's a lot of obvious impacts of it being hot along with it being uncomfortable, but it also contributes to high evaporation levels. So when we do get those small amounts of rain on a really dry soil, we're seeing high losses to evaporation rather than runoff into our water storages or into our groundwater systems. We have seen a significant drawdown on storages, particularly in New South Wales, both in inland New South Wales and northern New South Wales, but although we didn't go into it in this presentation, also along the coast with very low inflows. Groundwater levels are below millennium drought lows in many parts of the Murray-Darling Basin, and our outlook suggests that it's more likely that we'll have less than median rainfall over the next 3 months across much of Australia, and it will very likely be warmer than average.
Not great news, but thank you for sharing your expertise with us today. So there's a heap of links there on the For More information slide that you can look at more information on the Bureau's website. If we didn't get to your question today, we have an email, helpdesk.climate@bom.gov.au, but we will wrap up but take a couple more, just for those who need to leave us at 12. Our next webinar will be the Spring 2019 Climate and Water Update, and will take place on the 5th of September, so don't forget to register. That brings us to the end of our webinars today. A big thank you to both David and Matt for developing all that content and sharing your wisdom with us today. To our audience, we're thrilled we had a huge participation today. Thank you for your questions. We hope the session was useful and that you'll join us again. So as mentioned earlier, this session has been recorded and we will have the video ready for you for your on-demand viewing pleasure in the next few days, and we'll send you an email because you registered. So finally, but most importantly, we want your feedback. It is our aim to bring you the highest possible quality webinars, but we can't do that unless you share your experiences with us. So once we close the webinar, a short survey will pop up and we'd be very grateful if you fill it in for us. So thank you for those people who've joined us and need to leave now, and goodbye. And maybe we'll just do a couple more questions if that's okay, David and Matt. Yep, fantastic. We've had a heap of them. Angela, who do you think where's our next question?
Let's go to Philip, shall we? And on to summer, continuing stable conditions for more variable.
So David here again. I think there is some signs of positive changes as we move into summer. So the positive Indian dipole we have currently in place will almost certainly decline quite quickly as we reach the second half of November, early December. So summer is probably our best prospect for significant relief. Now, we don't have seasonal outlooks which go out to summer yet. They will come in a month or two. But I think we can look to a more normal summer. Hopefully we'll get some relief as we approach December and January.
Thank you. The next question was from Connor. Connor asked us, what factors determine whether the IOD is positive or negative? That's a tricky one. There's probably a heap of stuff on the website about that, but in short, David?
Yeah, look, there is a lot, and basically the IOD is an interaction between the ocean and the winds over the Indian Ocean. So when the winds become more easterly, we get a positive Indian Ocean dipole. When the winds become more westerly, we get a negative Indian Ocean dipole. So it's all there on the web. There's a video, complicated, but also can be explained fairly simply through interactives.
Thank you. Last question from Daniel. Is the filling of Lake Eyre going to make any difference to the rainfall outlook in the eastern states?
It's a very good and very long asked question, Daniel, and it stems back to a lot of early ideas of flooding inland Australia in the hope of making it rain more. That idea doesn't align with the science generally, and where they've done thorough scientific investigations into that idea has shown that the impact of having more water in inland Australia would not have a significant impact on rainfall in the east.
Thank you. And that's it from us today. That's all that we can take. Thank you so much to everyone for their participation today, our presenters and our participants. Goodbye. We'll see you another time.